All right. Okay, so we take roll real quick, make sure everyone's here, and then we will get started. One, two, three, everyone else is here. Okay. All right, so quadratic formula. How many people have heard of the quadratic formula? Raise your hand if you've heard of it. Okay, all of you have learned about it. You just might not remember it. It's something we cover in math 2 and math 3, but you start with it in math 2. Okay, so you guys have probably, if you've taken math 2, which all of you should have, you guys did it in math 2. You just might not remember it. Okay, that's why we go over it in math 3. Okay, so why do we use the quadratic formula? We use it to do one of two things: either solve a quadratic equation or find the x-intercepts. Okay, because remember, when I solve, I find the x-intercepts. Okay, now we've done methods like that. You had a quiz where you solved and found the x-intercepts, right? That was called factoring. Okay? That's one way to do it. So why do we use the quadratic formula? When we can't factor, when that's not possible. I'm going to show you some examples today where that's not possible. So there has to be another way. This is it here. There's good and bad about the quadratic formula. Obviously, you guys can kind of think of the bad by just by looking at it, right? Looking at it, it just kind of looks ugly, right? It's not that bad. Trust me, it's not that bad. But the nice thing about it is it always works. I call it Old Faithful. Old Faithful because it always works. If you need to solve, you can always use the quadratic formula. Those questions you guys had on your quiz last week, where you solved, you could have used this guy and it would have worked. You would have got the right answer if you did it correctly. Okay, but you guys we hadn't gone over it yet, so nobody used it, right? So it always works. Problem is, it takes a little longer than other methods. So we use it as the last resort, okay? But don't you see a bunch of A's, B's, and C's? We've seen those before, right? You guys know where those come from, right? A, B, C. So that's what we're gonna use, okay? So the first thing we need to make sure is we need to verify that the equation is in standard form. If it's not, change it to standard form. We've done that before. Make sure it's equal to 0. Identify A, B, and C. 1, 2, and 3 we've done before many times. Number 4 we've done many times. Factor. Factor means multiply A times C. Try to figure out what adds up to be B. That's factoring. Bottoms up. That stuff, that was factored. We've done that before. If that doesn't work, then we have to use the quadratic formula. Okay? And then the quadratic formula, we plug everything in, we simplify it, and then we separate and solve. Okay, so let's look at number 1. Let's look at example number 1. Okay. First question, is it in standard form right now? No, close, but not right now. It's not. There's no equal 0. So what I have to do is set it equal to 0. So to do that, I'm going to add y squared to both sides. Now, I can't add it over here because those aren't like terms. I can't add it right here. Those aren't like terms. But what I can do is add it over here, right? So what I'm going to do is I'm going to add it there. These make a 0. Okay. Danny, have your focus up here. I don't want to have to take away 10 points off to next week's test. Okay, so when I add it over here, I got 19y squared and I have 1y squared. That makes 20y squared. Okay, bring everything else down. Standard form. ABC. 20, negative 13, positive 2. Next step, A times C. A times C is positive 40. Now, are there numbers that multiply to be 40, but add up to be negative 13? Let's see, what are the numbers that multiply to be 40? 40 times 1, 10 and 4, 20 and 2, 8 and 5. So none of those, when I add them up, equal negative 13. But is there one that's close? There you go. Yeah, negative and a negative. If I do that, then adds up to negative 13. Bring it back over here now. Okay. So I have y minus 8, y minus 5, right? And then what did I do? What was the next step after that? Starts with a B. Bottoms up. Yep, divide them by A. In this case, A is 20. So I'm going to divide it by 20, divide it by 20. Now, 20 doesn't fit into 8. It's a fraction. I have two fractions, right? I have two fractions, one here and one here. So I can't divide fractions, but what I can do is reduce them, right? So if I reduce, what number divides, what's the biggest number that divides into 8 and 20? 4, right? 2, but 4 is bigger. So if I divide them by 4 and divide it by 4, I get 2/5. Same thing with 5 and 20. 5/20 is a fraction, so I can divide them both by 5. Divide by 5, divide by 5. You get 1/4. Whatever's left on the bottom, bottoms up. So 5 moves in the front, 2 stays. 4 moves in the front, 1 stays. And then what was my last step to solve? Separate and solve, right? Separate and solve. So separate this guy over here, equal to 0. Equal to 0. Add 2 to both sides over here. Divide by 5. I get 2/5. 2/5. That's already reduced. It's a fraction, so I can't divide it. Leave it as 2/5. Over here, I got to add 1 to both sides. Divide by 4. One-fourth. It's already reduced. It's a fraction, so I leave it as a fraction. So I hate that they use the letter Y for this one. I hate that they use the letter. I wish they use a different letter, because what are those two? Those two are my solutions, but what's another word for them? X-intercepts. They're my x-intercepts. They're very close to each other. 2/5 is 40 cents. 1/4 is a quarter. So a quarter and 40 cents are very close to each other. But that's where they would cross the x-axis, right? They're decimals. Remember when you guys were doing these guys here, when you guys were doing these, and there were some x-intercepts that you were looking at, and you were looking at your graph, and you're like, Mr. Flores, they cross the x-axis, but I can't really tell where they're crossing. It's kind of in between, right? That's what happens here. Okay, that's what happens here. Okay, so we didn't have to use a quadratic formula there. We didn't have to, because factoring worked, right? There were two numbers. When does factoring not work? Factoring doesn't work when this process right here, doesn't work. If I can't find two numbers that multiply and add, factoring doesn't work. So anytime that happens, I have to use quadratic formula. Well, that didn't happen here. So nothing changed. It was a review problem. Okay. So let's go to the next one, see if that's true too. Because on the test next week, I'm not going to say use the quadratic formula. I'm not going to say that. I'm going to say solve it. Now, you might have to use the quadratic formula. You might not. Okay. Okay, so let's look at this one here. 3x squared minus 2x minus 13 equals -6. Not in standard form yet, right? So I got to add 6 to both sides. -13 plus 6, -7. Move everything down. Okay. A, B, C. What is A? What is B? What is C? -3, -2, -7, right? Okay. Let's see if factoring is going to work. A times C. A times C. What is A times C? -21. What are the numbers that multiply to be -21? There's not many. 3 and 7, right? I could have a +7 and a -3. I could have a -7 and a +3. And then 21 and 1, right? Do any of those add up to be B, -2? No, right? No, they don't. Is there anything I forgot? Is there anything else that multiplies to be -21? There's not. It's not like there's anything else. This is when factoring doesn't work. So what do we say? We say it's not factorable. It's not factorable. We can still solve it, but this is not factorable. Because there's not two numbers that multiply to be -21 and add up to be -2. So then we have to use what you saw earlier, quadratic formula. Okay. So when I use quadratic formula, anywhere there's an A, B, or C, I put parentheses. So this is how I set it up. So -1 times B plus or minus the square root of B squared minus 4 times A times C divided by 2 times A. So there's no A, B's, and C's in mine. I left parentheses. Now I do that because that's where I'm going to plug in the numbers. If there was an A there before, I'm going to plug in what A is. If there was a B there before, I'm going to plug in what B is. It's important to do that because some of these numbers are negative, some of them are positive. And then if you look, I have a negative inside the square root already. Okay, so A was 3, so anywhere there was an A. So I have an A here, and I have an A here. So I'm going to go back to the parentheses, and I'm going to write A in there. 3, 3. B is -2. There was a B here, and there was a B here, right? So I'm going to write a -2 in there. And then the last one is C. C goes in there. Okay. So now I got to do some multiplication, some adding, subtracting, dividing. I have them all. I have multiplication, I have addition, I have subtraction, and I have a big division. Right. So let me simplify it. That's where that step is. Simplify now. Simplify. Step 6 says simplify. That's what I'm talking about here. Okay, so -1 times -2, +2, plus or minus -2 times itself. -2 squared. -2 times -2 makes a +4. Okay, minus. And then 4 times 3 times -7. 4 times 3 times -7. So 4 times 3 is 12. Times -7 is -84, right? Well, I already have a subtraction there. I had a subtraction before. So a double negative makes a positive. So it's really 4 plus 4, 84. Okay, Remy, do I have your focus up here? 2 times 3, 2 times 3 is the denominator. The number on the bottom is 6. So let me clean that up even more. 2 plus or minus the square root of 88 over 6. Okay. Square root of 88. You're going to use your calculator to find the square root of 88, but be careful when you use your calculator, because if you look at the top, it said we need to round our answer to the nearest tenth. Okay, so if you don't round your answer correctly, it's gonna be wrong, even if you did every other step correctly. So how do you round? Well, first of all, you got to go to your calculator. Let me go to my calculator. Oops, wrong one. So I know that the square root of 81 is 9, and 88 is pretty close. So it's going to be pretty close to 9. So I get square root 81. Oh, that's not what I want. Square root 88. And if you can't see, it says 9.38. 9.38. So 9.38 the tenths is the 3. 1 decimal place. Yeah, so that 8 is the one that's going to tell me whether I round up or down. That 8 means round up. Anything 5, 6, 7, 8, 9, round up. 0, 1, 2, 3, 4, stay where you're at. So now it's going to be 2 plus or minus 9.4 divided by 6. The last step says separate and solve. Remember when we separated on problem number 1 at the end, we separated them and solved and got 2 answers? We're going to do the same thing here. That's what the plus and minus means. The plus and minus means I want you to do both. First, add them together and divide, and then subtract them and divide. So we're going to get 2 answers. First one is 2 plus 9.4 divided by 6. And then the next one is 2 minus 9.4 divided by 6. Okay, so we add the tops, subtract the top, and then divide by 6. So let's see, 2 plus 9.4 is 11.4. Divided by 6 is 1.9. That's one of my answers. The other one is 2 minus 9.4 is negative 7.4. Divided by 6. Yeah, it's negative 1.23333333333 on and on forever and ever and ever. Well, again, we just want to go 1 decimal spot, the 10th. So we're going to look at the one next to the 10th, which is the 3 here. So that one says, yeah, this number here says, hey, stay where you're at. 1.2. Yep, sorry. You were right. It is negative. I dropped the negative somewhere. Negative 1.2. Those are still my x-intercepts. The u is going to cross at 2 places, 1.9, which is almost 2, and negative 1.2, which is close to negative 1. That's where it's going to cross the x-axis. Okay. So on the test, what I'll probably ask you to do is I'll give you an equation and I'll say which one of the 4 graphs matches up to that equation. If it's in standard form, this is one way to do it. Figure out, okay, which one crosses at 1.9 and which one crosses at negative 1.2. I'm telling you right now, there's only gonna be one of them. That's your answer. Okay. Or you can do what you did on this. Find the axis of symmetry, find the vertex. Is it arrows up or arrows down? Things like that. Okay. You can do the same thing as that too. This is one way to do it. Is this the only way to do it? No. You can do what you did on your here too. Okay. All right. Okay, so what I want you to do right now, I want you to do number 3 on your own. Do number 3. I'll give you about 5-7 minutes, something like that. I want you to do that on your own. Follow the steps, and we'll go over it like in about 5 to 7 minutes, okay? I want to give you a chance to do one on your own. Okay, so this one's not factorable. I tried to factor A is 5, B is 10, C is 2. So 5 times 2 is 10. I tried to figure out the numbers that add up to be 10. Close, I got 11. This one's 11 if I add them together. But that's not 10. It's close, but not 10. So it's not factorable. This one is just like number 2 is not factorable. So that means our only option to solve is to do the quadratic formula. Okay. So -1 times b, I'm going to put parentheses for b, plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, so I'm going to follow the quadratic formula just like on the first page. Everywhere there's an a, I'm going to put a 5. Okay, there's an a here and here. Everywhere there's a b, I'm going to put a 10, positive 10. Everywhere there's a c, I'm going to put a positive 2. Okay. Simplify. So -1 times 10 is -10. Plus or minus. 10 times 10 is 100. Square root of 100 minus 4 times 5 is 20 times 2 is 40. And then on the bottom, 2 times 5 is 10. Okay. So -10 plus or minus the square root of 60. So that's 100 minus 40 divided by 10. Okay. So now I go to my calculator and I figure out what is the square root of 60. 7 point something because it's going to be close to 64. Square root of 64 is 8. It's a little bit less than that. So it's going to be 7.4, nope, 7.745. This guy is going to determine the 4 is going to determine whether I round up to 7.8 or keep it at 7.7. Close, but I'm going to keep it at 7.7 because 4 is not quite high. If it was a 5, I would round up. Okay, so I'm going to separate it. So I have -10 plus 7.8 divided by 10. And I have -10 minus 7.8 divided by 10. Yeah, why did I change it? Yeah, you're right. Thank you. Spent all that time saying to keep it and I change it. 7.7, thank you. So in my calculator, I'm going to do -10 times -10 plus 7.7. I get -2.3 divided by 10. I get -0.23. Over here, I get -17.7 divided by 10. I I get negative 1.77. This guy and this guy right here are going to determine whether I round up or stay. 3 is too low. It's not high enough to round up. So this one's going to be negative 0.2. This guy over here, this 7 over here is high enough, so I can round up. So that one's going to be negative 1.8. Okay. All right. Okay, let's do one more. All right, so let me rewrite this. Okay, first thing I got to do, it's not in standard form yet. I got to set it equal to 0. A couple things I need to do first. I need to subtract 2x squared from both sides. So the only one I can subtract it from is the other one with x squared. Okay, and then the next one I got to do is subtract 6x from both sides. Two x squared plus 18x plus 13. Now it's in standard form. Set equal to 0. A, B, C. 2, 18, 13. Multiply A times C. That's going to be 26. The only way to make 26 is 13 times 2 and 26 times 1. Or negative, or you can make them both negatives, but still, none of those are going to equal 18. There's nothing else that makes 26. Besides, I can change them both to negative, but that's still not going to help me out. Not factorable. Okay. So let's set up quadratic. Okay, so everywhere I see an A above from the original on the first page, I'm going to put in a 2. So I see an A right there, and I see an A right there from the first page you guys had on the front of your booklet. Everywhere I see a B, I'm going to put in an 18. That's right there. That's right there. And then C goes right here. Okay, simplify. Negative 18 plus or minus. 18 times 18 is 324. And then I got 4 times 8, or sorry, 4 times 2 is 8, times 13. 104. Over 2 times 2, which is positive 4. So negative 18 plus or minus the square root of 220. 324 minus 108, or sorry, 104 is 220. So the square root of 220 14.832. Okay, so the 3 here says stay, so keep the 8 the way it was. So the last thing I'm going to do is I'm going to solve it twice. Negative 18 plus 14.8 divided by 4. And then negative 18 minus 14.8 divided by 4. Okay, so 18, negative 18 plus 14.8 equals negative 3.2 divided by 4. Divided by 4 makes negative 0.8. Last one, negative 32.8 divided by 4 is negative 0.8. Negative 8.2. Those are my x-intercepts. Okay. So when you do these, when you're doing these problems, don't pack up yet. We got plenty of time. If you want to pack up early, I got a couple other things we can do. So if you don't want to do anything else, just focus up here. If you're still writing some of this down, that's okay. But other than that, I should see your focus up here. So when do I have to do quadratic formula? It's a lot of work. When do I have to use it? Yeah, Giovanni? There you go. Good. Can anyone tell me how I know it's not factorable? When do I know that? Because Giovanni was absolutely correct. It's not factorable. When do I know whether it's factorable or not? Right? Close. When A times C and doesn't equal B, that's when it's not factorable. That's when I have to say, can't do it. Great. Now, this guy right here, number 1, we didn't use quadratic formula for number 1, right? Could I have? Yes, it would have worked. Guess what? I would have got 2/5 and 1/4 as an answer. It would have worked. Okay, quadratic formula works. We just use it. We don't use it unless we absolutely have to, because you saw how it looks, right? But if we have to, that's the only way. Okay. Yeah. Yeah, some questions will. On a test, I'm not going to tell you which method to use. I'm not going to say use factoring or use quadratic formula. Okay. You have to realize, well, try factoring, and if it doesn't work, you got to use quadratic formula. Okay. You should get the same answer. You should get the same answer. Yeah. Yeah, Alexis? Oh, okay. As long as it's the same decimal, you're okay. Yeah. Yeah, because here we put 2/5 and then later on we put them in decimals. If they're the same, like if you put 0.4, which is the same, that's okay. If you put 0.25 or 0.3 for 1/4, that's the same. As long as they're the same, you're okay. That question I can help you with. Like if you're like, Mr. Flores, I don't know if I should change it to a decimal or keep it as a fraction. That question during a test, I can help you with. I can help you with that question. I can't help you with, what do I do after this? I'm stuck. Can't help you with that question. Okay. That's where your notes come in. Okay. But yeah, that kind of question I could help you. All right. Okay. So Mariana Bird, behind you, there's some tape. So I need you to tape these in. Okay. No assignment today. We're going to work on it tomorrow in class. Okay. So I'm not assigning anything new. The only thing is your posters. If you haven't turned them in, get those in so I can put them in the grade book.